Welcome to Sinusoidal Applications. SpongeBob drove over a tack with his tire. If the tire has a diameter of 20 centimeters, determine the equation of the cosine function that expresses the height of the nail from the ground as the tire continues to travel. So, my radius, therefore, is going to be 10. And so, since we're dealing with a tire, you're going to, if I want to figure out what one period's going to be for it to go, the tack to be on the ground, to go to the high point, and go back to the bottom, is going to be C equals 2 pi r. That's the circumference of a circle. So my circumference is going to be 2 pi times 10. So 20 pi is going to be my period. So let's draw a generic graph. So we're going to go from 0 to 20 pi. So it's going to go from the ground to the ground, 20 pi, 10 pi is the middle. And so my tire has a diameter of 20 centimeters. So that means from the top to bottom is 20 centimeters. So at 10 pi, it's going to go to the top. So this is my upside down graph. If I'm going from the nails on the bottom, I go to the diameter of my tire, which is 20, back down to 20 pi. So it takes me a period of 20 pi for the nail to return back to the ground. So if I do my highlighter, here's the middle of my graph, here's the beginning of my graph. My amplitude is right here in the middle, that's 10, and because I'm upside down, it's negative. My period constant, let me pick a different color. Oops, I don't want to use purple. Let's use a teal. Okay, so my period constant, my B is equal to my 2 pi over my 20 pi, which is going to give me 1 over 10. 1/10 is my period constant. Then for my shift, let's use orange. I didn't move over the right at all, and my vertical shift is up 10. And so there are all my values for the tack in the tire going from the ground up to the top, back down to the ground. On the last slide, we saw that my amplitude is negative 10, my period is 1/10, my phase shift is 0, my vertical shift is 10, and since this was an upside down cosine graph, my equation is going to be y equals negative 10 cosine 1/10 x, and since I'm not moving anything right or left, I'm going to just leave it as x plus 10. If I want to know how high off the ground the tack is after it's rolled 150 centimeters, I'm basically going to plug in 150 centimeters in for x, and if I do that, we're going to get 17.597 centimeters. It's just plug and chug. Okay. 2. As you ride a Ferris wheel, your distance from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts, your seat is at a position shown in the figure. Let x be the number of seconds that have elapsed since the Ferris wheel ride started. You notice at 3 seconds you are on center level heading towards the top, 43 feet above the ground. The wheel makes a revolution every 8 seconds. The diameter of the Ferris wheel is 40 feet. So, to sketch a graph of this, okay, you notice that at 3 seconds, you're on the middle of the graph. Or you're at the center of the Ferris wheel. And it says you head towards the top 43 feet above the ground. So this is 43 feet. Now, if the wheel has a diameter of 40 feet, that means the lowest it can go is 3. So therefore, halfway in between is at 23 feet. So at 3, you're at 23. It takes you 8 seconds to complete one revolution. So 3 plus 8 gives you 11. So at 11, you're back at the center. So at some point, if this is going to go up, then come down, and then go up, I'm going to basically be back at the center halfway through, which is at 7. 5, 9. At 5, I'll be on my way up. 7, I'll be back in the center. 9, I'll be at the lowest point, and 11 back in the middle. So here is my sine graph for 1 revolution. Here's the middle of my graph. Here's the start of my graph. So my amplitude is 20. And since this is starting at 0 up, 0 middle, 0 up, 0 down, 0, I don't need a negative on it. My period constant, my period is 8. So 2 pi divided by 8 gives me pi over 4. My phase shift, I went to the right, so that's 3. My vertical shift, I went up 23. So on the previous screen, you saw that we had an amplitude of 20. My period constant was pi over 4. My phase shift was 3. My vertical shift was 20. And this was a sine graph. It looked like this. So my equations, y equals 20 sine pi over 4 x, and since I'm going 3 to the right, that's a minus 3 plus 23. So if I substitute in for part D, 6 seconds in for x, 9 seconds in for x, and 0 seconds in for x, you just type this in the calculator. Make sure that if you're using pi over 4, that your mode is on radians in order to get a proper answer. And so for 6 seconds, you should get 37.142 feet. 9 seconds is 3 feet. And 0 seconds is 8.858 feet. All that is substitution. Just plug 6 into x, 9 into x, 0 into x. Okay, 3. Emily is at summer camp. One day she is swinging on a rope tied to a tree branch, going back and forth alternately over land and water. Pierre starts a stopwatch. When x equals 2 seconds, Emily is at the end of her swing, y equals negative 23 from the riverbank. When x equals 5 seconds, she reaches the other end of her swing where y equals 17 feet from the riverbank. Assume that while she is swinging, y varies sinusoidally with time. So for my graph, it says at 2 seconds, she reaches negative 23 feet. Then it says at 5 seconds, she reaches the other end, which is 17. So 3 seconds elapses between the 2 and the 5. So 3 more seconds would take me back down to a low of 8. So these are the two extremes. This is the farthest she can go over land, and this is the farthest she can go over water. And so halfway in between negative 23 and 17, if you find an average, is negative 3. So here's the middle of my graph. Here's the start of my graph. This is just an upside down cosine graph. So my amplitude, if I check from negative 3 to 17 or 3 to 20, is going to be 20. But since I'm going upside down, I'm going to put a negative 20. My period constant, my period goes from 3 to 8. So from 3 to 8, or sorry, not from 3 to 8, 2 to 8. Let me erase that. 2 to 8 means my period is 6. So then 2 pi divided by 6 gives me pi over 3 for my B. My phase shift is my 2. My vertical shift is down 3. So on the previous screen, we saw that your amplitude is negative 20. My period constant was pi over 3. My phase shift is 2. My vertical shift is minus 3. And this was an upside down cosine. So my equations, y equals negative 20 cosine pi over 3 x. Since I went 2 to the right, it's a minus 2 down 3. And again, just like on problem 2, if I want time equals 2.8 seconds, 6.3, 15, and even 0 down here, all I have to do is plug 2.8 into x, 6.3 into x, 15 into x. In this case, your x is your time, and y is the distance that you are from the riverbank. And then time equals 0. So if I plug those in, I'm going to get negative 16.23, which means that's how far you are from the water. If I plug in 6.3, I'm going to get 1.16. That's how far you are from the bank. Okay, so this basically means that you're on land and you're that far from the water. 1.16 means you're over the water and you're that far from the bank. 16 gives me negative 13, which means I'm that far over the bank from the water. And at t equals 0, that's 7 meters from the bank. And since it's positive, it means I'm over water.